Alright, we're good to go to the results section. So we go to the visual viewer. Alright, from open file, we go to the 3D MMAW results and we go for post 1000 FTB. And here is our model. If we want to go to the temperature node results and temperature node, okay, as you see here, the highest temperature during the process reached to the 2300 roughly, and we're going to play the animation to see how it moves. Okay, I want to stop and go to the other side of the weld. So let's set this one on 1500, or better say 1400, which is the melting point of the 316L. It is between 1357 to 1400. Now here it is, and as you can see here, it is fully melted, the root pass, and so the root of the weld is fully melted, and we can conclude that these parameters are good parameters of welding. So let's see the video, the animation once more from here. So here it is, the moving heat source and the torch of the welding. It moves from this side to this side, and then we wait for the cool down until it uniformly cools down to the room temperature. Yeah, that's it. So imagine that we want to export this video. What we can do is to go from here to file, and we can select the save image /movie/report. So here we can select this one on image or movie. We can choose the format of the file. Let's say it's animated GIF, and we hit on save, and we select the destination of the file, then save. We can choose the frame per second or the FPS, everything else. Now he said it's succeeded, and we can open it from here. As you see here, it is the heat source is moving, and there are other informations here. Right, so if you want to increase the speed of the animation, we can change it from here. So if we want it to move faster, we can change it from here. It goes faster and slower, or anything you want. Alright, now let's go to the middle part. It's kind of in the middle. Right now we want to import and plot. We want to go to the import and plot. So from here we can do some cool things like exporting the graph of temperature, versus node, we can select the node. So let's change this one to the top view, and or we can go to the final time of the weld, like here as we are. Let's say here, and we want to see the temperature versus second. You can select the node, for instance, one here, one here, one here, and we can see a gradient of the node. So we want to plot it. Now here we see the details of this file, or you can export this one, export curves. Here you can export it in CSV file, and it is tab delimited, so we can do that in Excel to get better visualization. So here we have different nodes, and we can come back to the page 1 and see what happens if we want to go from a path and plot our results in a path. So we go to the top view, and we can say, let's say here, which is in the middle. So we select this one, as we can see the nodes on the mesh here. So once more we go to the import and plot, and instead of the node we can select profile curve, and by clicking this one, create profile curve, you can create your own profile curve. So we want to create a profile from here, let's say like something like this. You can do it yourself and go nodes by node for a better outcome, but I want to do that roughly. So if we select one node wrong, we can go to the sequential undo, and we select this one and this one. So we created a path, and by clicking on this one we apply it, and as you see the profile curve is here. So we want to plot the temperature node on our profile curve. So we can either select a new window, or we can do the override. So we do the override and see the temperature gradient by the distance. So this is the temperature degree, and by distancing from left to right or right to left side of the weld, here we see the temperature is different. It is highest in the middle. So once more we come back to here. We can do this on the transverse direction. This path is really useful when we want to do the residual stress analysis, which are in next videos, but here we can see cool things like this. Alright, now we come back to the isometric view, and we can go through the phase change. So from the contour here we can do the phase change, and first phase here it is the first phase. We click on that. Right, so it's our this is our material, which is a austenitic steel, stainless steel. So these are the austenite, and this is the filler material. So number 2 is the filler material. If we come to this side and we go further and further, we see that the material is all uniform by the end of the process. And this is the filler material that is fully used, so we have no residual of the material by the end of the process. So we consider this as we consider the parameters as a good parameter by seeing this result. What else we can do is to go to the contour. There are other things here. We can see the heat flux. This is the heat flux contour, which is not as useful as you see, but sometimes people need that, or we have the grain size. I'm not sure whether this is accurate enough, and we have the object distance here. We can select that to distance to see that distance, but it's pretty much everything. So we did the thermal analysis of a 316 stainless steel L in 3D. The objective of this video was to do the calculation in a 3D model, so it's important to know the parameters and set the parameters. If you check the results and see there are any residual material left, so we can go further back and do the analysis again. Or if you want to makes it perfect, you can select other parameters and see what happens if we go with higher speed or lower speed. You get a really good understanding of the welding process you're working with. Alright, I hope you enjoyed this video. See you in the next video. Bye.